Yeah. Yeah, it was actually the slides that I used for the presentation video. Yeah. So yeah, this is the paper's name is AMUSE, the Human AI Collaborative Songwriting, with Multimodal Inspirations. So I'll probably start by giving you some motivation. So you may also know that music creation is often inspired by a variety of sources that could like start from music, but they could also start from the other modalities. So for example, um, you might know the famous classical piece composed by Modest Mussorgsky, and it's the pictures at an exhibition, and it was actually inspired by the Russian paintings. And one of the popular pop songs composed by Olivia Rodrigo, the driver's license, is also known to be inspired by her diary entry. Um, there are like music AI technologies out there that are trying to help creation of music AI, but I contend that these music AI systems lack support for integrating these kind of various sources of inspirations into songwriting process. The current music AI landscape is can be divided into two categories. The first one is the text to audio generated AI. So these can offer user control by giving them ability to control the music output by the text prompt, where users can somehow like translate their multiple inspirations to some kind of text descriptions and get the music that kind of confirms to their inspirations. But the problem here is that the outputs are primarily the rendered audio, the raw audio output, which is not reusable in the creator workflow. And the other one is the sampling music AI, which inputs and outputs the reusable elements such as MIDI data. But currently, due to lack of data set, like paired data set of multimodal inspirations and music data, it cannot really give users a control like to input their multimodal inspirations and get the outputs that conform to their initial intentions. So the core question is how can we better support songwriters integrating inspirations within their iterative songwriting processes? So yeah, the core take the summary of the project is that we developed a songwriting assistant that transforms multimodal inputs, which are images, text, and audios into chord progressions that can be seamlessly incorporated into songwriters' creative process. So, to inform the system design, we conducted a formative study with 8 songwriters. So we basically did a semi-structured interview that lasted about like 1 hour, where we asked about songwriters' sources of inspiration in their song development process, and also we asked about potential AI supports that could enhance their songwriting process. So we got like 3 major findings from this interview. The first one is that musicians get inspirations from diverse modalities, as I mentioned in the motivations. This could, yeah, this could be categorized into 3 categories, which is first narratives, for example, stories or anecdotes, personal experiences. And the second one is visuals. For example, someone said, some interviewee said he got inspiration from action movie scenes. And the last one, the most prominent one is music, where they listen to existing songs and try to transcribe chords or melodies they like and start from there. Um, but they said they spend like significant amount of time manually translating these inspirations into musical elements um, that they can use to build their song. So what they did was primarily improvising with their instruments or voices until they get something they like, or they took like in a yeah, they were involved in a deep listening session to analyze music and get what they like. So, despite this manual process, they found AI valuable for this kind of inspiration seeking process and translation process, especially if it generates controllable and editable suggestions, which means that they preferred AI outputs that give some agency and ownership to their workflow. Based on the formative study findings, we established three design goals. So first one is to incorporate multimodal inspirations. As identified in the study, we decided to incorporate visual narrative and existing music. And the second one is we should help musicians transform their abstract ideas into concrete musical elements so that the output ensures that it aligns with users' creative intentions. And the last one is we should provide modular musical building blocks that can be edited and directly integrated into their songwriting workflow. For example, their interfaces, digital audio workstations, and something like that. So we came up with AMUSE, which transforms multimodal inspirations into chord progressions. So firstly, it supports diverse sources of inspiration, which are texts, image, and audio. And okay, it also transforms these inputs into musical elements, which we decided it to be chord progressions, which is one of the fundamental musical building blocks and which can be seamlessly integrated into the songwriting process. Um, so Muse has two main features, which are Chord Generator and Chord Transcriber. So the first one is the Chord Generator, which consists of two-step pipeline where users first extract the music keywords from their multimodal inspirations, and then using these music keywords, they generate the chords that conforms to the music keyword that input. Yeah, and okay. So the second one is the chord transcriber. So in this case, users can input their favorite songs. They can input the YouTube URL or their audio file to transcribe chords from this audio. And then after they get the chords, they can click the chords and then it will be directly integrated into their songwriting interface. Yeah, so the problem, so the chord transcriber, it was relatively straightforward because we could use the established chord transcriber API that is proven to be good. But when trying to generate the chords based on the user music keywords, we found that this is actually challenging to actually achieve the qualities that should be achieved for like ensuring the user experience. So we defined the three desiderata for this keyword-based progression generation, which is first diversity, ensuring that users get a variety of options, and the second one is relevance. So in relevance, we should ensure that the music keywords and the generated chords are relevant to each other. And the last thing is coherence. So in this case, we ensure that the generated chords are actually musically coherent, meaning that it actually follows the real world music data distribution. So ideally, we could have like a single model that can accept the user keywords and generate coherent chord progressions that are relevant to these keywords. But the problem is that we don't have the paired keywords and chord progressions data. So directly training this model was invisible at the time of development. Instead, what we had was first the noisy generator, which is LLM, that can take the user keywords and generate some chord progressions in text. But we assume that this is noisy because although LLM is trained based on a wide range of text data, it is not explicitly trained on the music data. So it might not capture the music distribution accurately. And the second one is we have the unpaired real-world chord progression data, which means that we don't have the music keyword associated with the chords, but we have like sequences of chord progressions that are actually used in music. So what we did was rejection sampling the LM generated noisy chord progressions. So first, we generated the chord progressions using LLM by prompting technique. So as a result, we could get a diverse and relevant keyword chord progressions, but these are noisy because these models are not trained explicitly on the chord progression data. And then we trained a separate unimodal chord generation model using the real-world unimodal chord data. So this is not conditioned on music keywords. So the outputs of the model be irrelevant to the music keywords, but it can generate the coherent chord progressions because it follows the real music data distribution. So using these two, we tried to first generate the noisy chord progressions using LLM, and then we reject the ones that deviate from the real chord data distribution with the unimodal chord model, resulting in diverse, relevant, and coherent chords and then these were returned to the users. So we did some technical evaluation to prove that our chord generation method is coherent, relevant, and diverse enough. So we first evaluated our prompting method. I didn't elaborate on the prompting method in this presentation, but when generating the diverse, relevant, but noisy chords, we had a specific prompting method to encourage model to output diverse chords as much as possible. So what we did was we measured the diversity of the generated chord progressions using the self-blue score, and then compared our method with the conventional method where the suggestions are generated per query. And the result is that we identified that our method is capable of generating more diverse chord progressions than the baseline. And secondly, we evaluated whether our chord generation method can produce coherent chords that are relevant to keywords using both automatic evaluation and also human evaluation method. So for the automatic evaluation, we use the Jensen-Shannon divergence, which measures the similarity between the distributions of two data. And then the second one that we used was we conducted a listening study with 45 music listeners and tried, we decided the human preference of chord progressions between our method and the baselines. And the conditions that we used was firstly our method, the rejection sampled LM chords, and then the other one, the second one was GPT-40, which means we just use the chord generated solely by LM, but not by the rejection sampling. And then the last one is unimodal chord model. So this is not keyword conditioned, and it's generated using only the unimodal chord model, and it's closest to the real world music distribution. So the automatic evaluation. So from the automatic evaluation, we identified that our methods generates the chords that are closer to real music data distribution. So the unimodal one is the closest to the real world data distribution. And you can see that our method is closer to the unimodal chord model, which is the closest compared to the GPT-40 generated chords. And secondly, from the listening study, we found that human listeners think AMUSE's chords are natural as real-world chords, where we didn't find any statistical difference between the unimodal chord model and AMUSE in terms of the musical currents of the chord progressions. But we found that GPT-40's chords are not coherent as AMUSE because we identified the statistical significance between the difference between the human preferences. And lastly, human listeners found AMUSE's chords more relevant to keywords than unimodals. So unimodal is not keyword conditions, but our AMUSE method is keyword conditioned. And yeah, we could confirm that listeners can identify the difference statistically significantly. And then to gather insights there, like how people use our system and what's their perceptions or what could be done in the future work, we did some user study with 10 songwriters. So to give a little context, we sent the announcement to the HookPad users. So the HookPad is one of the famous songwriting interface where users can sketch the melody and chords. And there is a modal chord area. So in this figure, you can see the this little box where area can accept user melodies or chords and then generate the infillations or continuations of chords and melodies based on the user musical input. And there is a system AMUSE, which is embedded as a Chrome extension where users can upload their multimodal inspirations and get some chord progressions. And then clicking the chords will directly integrate these chords into the interface. So we gave the task, two tasks about writing an 8-bar chorus about certain songwriting prompt, which was the first one was the unexpected friendship that you had in your life, and then the second one was your favorite summer holiday memories. And then we compared two conditions where the first baseline is using only area, which reflects the existing songwriting, AI assisting songwriting workflow, and then the experimental condition called assist, where users were using both area and AMUSE, which means they got both tools in their hand. So I'll just summarize interesting findings from the user study. So the first expectation we had from like users using AMUSE and ARIA together was that people would be using AMUSE in their very early stage of songwriting, meaning they could start their songwriting process by inputting their multimodal inspirations and develop the song, open the chord progressions, and never come back to AMUSE. This was certainly the most major case where we named this as Kickstart with multimodal inspiration. So in this case, they use AMUSE at the start of songwriting and did not return to it, but they use ARIA for melody creation and stuff like that. But we did discover some interesting use cases where people use the AMUSE in the middle of the process. So we named this as an ad hoc inspiration flow because we identified that people get inspiration in the midway of the songwriting process and using AMUSE to incorporate, translate these inspirations into the song. To borrow some user quotes, they mentioned using like AMUSE sparked further inspirations, or the inspirations came midway through the songwriting process. So the right figure is the visualization of the tool usage throughout the songwriting process in the user study. And for example, you can see that P4 first used the chord generator and then moved to the chord transcriber. So in this case, the user was inspired by the chords produced by the chord generator and suddenly thought of the song, which was Billie Eilish's Birds of the Feather, and then tried to transcribe the chords from the song and then integrated that into their songwriting workflow. And the last one was the lyric center brainstorming. So this was a pretty unique case because just one user tried this. But this user outlined the song with the lyric ideas. So he assigned the lyric to each verse and then used the AMUSE to generate chords for each bar by bar, and then develop the song after like getting all the inspirations using AMUSE. And we also conducted a post survey with the users where we found that using AMUSE granted users more agency and creativity to the users. So in this graph, you can see that when we asked that like about whether the songwriting process was controllable, like the AI tools, whether the AI tools during the songwriting process was controllable and collaborative, we could see the statistically significant difference between the baseline and assist condition, where users thought that using AMUSE they could be part of the creative process, and you can tell the AI tool what you want. And when we asked about whether AMUSE helped fostering creativity during the songwriting process, they also show significantly different results compared to baseline. So when we ask whether AMUSE allowed exploration of different ideas, people said AMUSE is liberating and they can actually guide the tool toward what they want to create. And then we also asked whether using AMUSE on top of ARIA and HookPad allowed more expressions and whether they felt more expressive during the songwriting process. And then the answer was yes. And then, for example, like someone liked the picture input because it's easier to convey their idea when like rather than just trying to convey their idea as text. Very interesting point that we discovered is that their enjoyment and their satisfaction towards the final composition they had little difference. So it did not discover any like statistically significant difference between the two conditions. And we contend like from the interview data, we found that using like without AMUSE, which gives some users some control to the AI outputs, they perceived the area, like the conventional like music, human AI music creation workflow, could be serendipitous because the random outputs could be sometimes very interesting and could be inspiring in their creative process. Yep, so these were the notable interesting findings from our study. And the other finding that we found interesting was that in the assist condition, we gave two kind of tools. And then users seemed to have a sense of disconnections between the tools when using these tools. And from the interview, we identified that participants formed assumptions about one tool's capability based on their experiences with the other. So they appear to have expectations that both tools will generate the suggestions based on both the multimodal inputs and the contextual inputs, which means the music elements like melodies and chords already in their editor. But in fact, the system's capabilities was different. So ARIA can generate their outputs based on the musical elements already on the editor, but it cannot take multimodal inputs as their control. But AMUSE is opposite, so it can like take the multimodal inputs, but it cannot like take the contextual inputs already in the editor. So there was some occasions where people felt like a sense of disconnections or frustrations when their expectation like conflicted with the reality. Like for example, a person like one participant inputted a children's like her child's picture and then got some playful chords from the AMUSE and then expected ARIA to generate something playful that is like still like conforms to the multimodal inputs, but ARIA did not, which from which she was pretty disappointed by the results. So from these findings, we identified interesting design opportunities for human AI musical creation systems. So the first fundamental thing that we could work on for the future project is like how we can make a system both multimodal and contextual, like meaning that like how to create a model that can take both the multimodal inputs and user contextual inputs. And the fundamental problem, like challenges, lying in this area field is that we don't have the paired data set that has like multimodal and like information and the music information at the same time. And you know, like creating this kind of data set could be a huge addition to this field. And the second one is the output preferences, because we found that controlled suggestions and random suggestion can like bring joy and satisfactions to the user songwriting experience. So the question is how can we balance our user output preferences in music creativity support tools? And lastly, it's really interesting question that I'm currently interested in. So it's the creation context. So in our project, we developed a muse, assuming that people are sitting at the computer and composing the song. But the music itself is pretty dynamic, so it stems from users like playing their instruments or experimenting with their voices, which means that music is created by improvisation. So what should be considered if AI was to support users when improvising with instruments? That could be also a very interesting avenue to take. Yep. So this wraps up my presentation about AMUSE. We present AMUSE, songwriting assistants that support users in transforming their inspirations into musical elements, and we propose a chord generation method for like generating diverse, relevant, and core and chord progressions. And we present insights from user study on like how people incorporate inspirations into their songwriting process. Yep. Thank you for listening to my presentation. Mhm. Yeah, I have very little background on the music hall design and all these like architecture stuff. But I guess your last comment about like whether we should give more control or give more inspirations by like providing like uncontrollable but like in high quality, complete but diverse outputs. If I understood correct, it's really an interesting question to explore. Yeah, I totally agree with your insights. That's the research, like, overarching research question that I'd like to pursue throughout my PhD journey, because about the recent text to music generation models. For example, like Suno and Udio, these are like fascinating. I tried a lot of like text prompts and lyrics, and they are capable of producing like such a nice like high quality songs. And this is actually like attracting many communities, but I contend that these are not really designed for musicians. Like people who are actually interested in this kind of technologies are not really music related. They are rather like content creators who are trying to create some background music for their like video, or maybe someone trying to create some contents like shorts that could be, you know maybe I've encountered very interesting like shorts that made the songs out of the chat logs. It was like funny. So I I think like trying to understand like how what musicians want, how they create music, and trying to like blend AI into the process so that it can actually help them create music more efficiently or in a like surprisingly like new like novel way that they really want to use. So I have to view like when in the past when the synthesizers and the like these kind of sound design stuffs were out, I bet people were like like in the same way negative about like towards this kind of technology, thinking these are taking away their creation, like joy of creation. But nowadays, like synthesizers is like one of the you know most necessary like elements, like the tools that musicians use to create new music. And I believe that there would be some way that AI could do the same, like revolutionizing the way they create music and helping musicians create like express their creativity like even better than the past. So yeah, that's my view. Yeah, yeah, it's a really good point. I have actually like witnessed some like user like concerned about the integrity, like if they're going to use AI in their creation process. Like it's like same like it's about the music generation models like Udio and Suno. They were super worried about like whether the generation is like actually so they were like super worried about the integrity of the generation. Like they were worried if they're gonna use this like generated music, if that could be like subject to some copyright issues, because they know that these models are trained on like vast amount of music data that could be copyrighted. So yeah, I think the retrieval augmented generation method could be a great solution to these kind of user concerns. Like if we can indicate this that these generations from this music, then they can compare the generation and the original music, and then if they like some part, they could probably extract. And if they're worried about that, they could probably like find another way, like find different paths or different idea. It could be also like a uh, great, great solution to the current music AI landscape. And one thing that I noted about is there was one user from the formative study mentioning that generating like smaller modular musical building block is like a little bit free from these kind of integrity concerns because they can anyways edit the suggestions, and then it's like very small like fragment of the music, and then that could probably be developed in a very different way from the original music. So yeah, again, I think that like reusable and like modular, smaller suggestions could be a lot helpful to the designers or songwriters, musicians, and stuff like that. Thank you.